Hello everyone, welcome to the Unit 3 study guide, part 2 video for guided notes for preparation for the final exam. We're going to jump right into number 39. We're going to solve the inequality and use the number line to test the intervals. So we're going to find the zeros and then test intervals on either side of those zeros. So I'm going to split this because it's a 4-term polynomial. I'm going to split it in half, and then greatest common factor of both sides. That would be x squared and 2x plus 5. And then over here, let's see, 32 and 80 are both divisible by 16. I'm going to factor in negative 16 and get 2x plus 5 in here. So this factors into x squared minus 16 times 2x plus 5. I use this to find my roots, which means x is equal to 4, negative 4, and negative 5 halves. Those numbers go on the number line, 4, negative 4. They get open circles because of this. I want to figure out where this function is positive. And then negative 5 halves would be negative 2.5, so right in there. So I'm going to test intervals and plug in numbers into this function. So I'm going to plug in numbers that are maybe easy to work with. I'm going to test maybe where x equals 5. Not too big. So x squared, so 5 squared would be 25 minus 16 times 2 times 5 is 10 plus 5 is 15. So when I do that, I get a positive number. So I can check off this area here. If I want to test a value between negative 4 and negative 2.5, I'll test negative 3. Sorry, that was negative 5. Oops. I tested, okay, fine, that's fine. When I test positive 5, then what happens is, and I just did this in the wrong area. If I test x equals 5, that's fine. That would be this area out here. That is positive. Now let's test where x equals negative 5 and see what happens. Negative 5 squared is 25 minus 16. That's going to be a positive number. And then 2 times negative 5 is negative 10 plus 5. That's negative 5. That's going to end up being a negative number. So as it turns out, that value is not, does not make the function, does not satisfy this inequality. It does not make the function positive. Now, when x equals, let's test a number here between negative 2 and negative 4. Let's test negative 3. When you square negative 3, you get 9 minus 16. That's a positive number. When you take 2 times negative 3, you get negative 6 plus 5. That's negative 1. So you're going to be multiplying a negative times a negative. You're going to get a positive number. That works there. Now we're testing a value between negative 2 and 4. I'm going to test x equals 0. So when I plug 0 into this function, I get 0 squared times negative 16. And then when I plug 0 in here, I get times 5. That gives me a negative, and so that is not where the function is positive. That is where the function is negative. And so if I were to graph this function quickly, it would have, it's a cubic polynomial, and it has a root at negative 4, at negative 2.5, at positive 4. And so it's cubic, so it's going to have opposite end behavior. Has 3 separate roots, starts low, goes positive, comes back through negative 2.5, goes negative for a while. That shouldn't have happened. Goes negative for a while, and then comes back up through where it goes positive again. I don't know if these are the exact dimensions of this, but it follows this pattern. Then it's negative, positive between negative 4 and 2, negative for all x's between negative 2 and 4, and then positive again over the interval for x's greater than 4. You can always double check this on your calculator by typing it in and seeing what it looks like, but I want you to be able to use the number line and test to find out where those roots are, where the function is positive and where the function is negative. Thanks for watching.